Okay, so like I said, we're filling out this chart on page 25. The first thing you have to do is decide how each type of rock, clastic, crystalline, and bioclastic, are classified. So how they're put into groups. So for that, you're just going to look at the reference table and you're going to look at the clastic group. And you see that there are 5 different clastic rocks: conglomerate, breccia, sandstone, siltstone, shale. So if I handed you those 5, like a pile of rocks, how would you separate them into 5 separate groups? Conglomerate, breccia, sandstone, siltstone, and shale. What size of? Yeah, the size of the grains are what makes the clastic rocks different from each other. So if I handed you a pile of clastic rocks, you'd put them in these 5 groups based on their grain size. So that's what's going to go right in here. Clastic is classified by grain size. All right, now you guys want to keep going on together, like in groups? In groups, go ahead. In groups or by yourself. See if you can fill in the rest of this back from your reference table and or the notes we took on page 23. All right, so you guys had some time to kind of pull that together on your own. Let's see how you did. Make sure you have the right notes. By the way, these are notes. So if you ended up writing something different than we are going to talk about together, make sure you go back and change it, because this is stuff that you do need to be able to see right off the reference table. So starting from the beginning, and I didn't ask you to do this, is sedimentary rocks. What can we say about sedimentary rocks in general? They're formed from sediments, and what happens to those sediments? Okay, in the long story short, they get cemented together, yes. So what you do need to remember, so again, how do you read this reference table in case you forgot that? Backwards. So if you find sedimentary rocks and read them backwards, they form when sediments get deposited, buried, compacted, and cemented together. So we're going to put that right on the top here. So sediments get deposited. So deposited means dropped off, buried, compacted together, compacted and cemented together. So all sedimentary rocks form when sediments get deposited, buried, compacted, and cemented together. What makes each sediment or each type of sedimentary rock, so there's 3 types: clastic, crystalline, and bioclastic. What makes those different is mainly what the crystals are, what the sediments are that are getting deposited, buried, and compacted together. So we'll start by clastic. We already said that clastic rocks, and by the way, here's 3 examples of clastic rocks, which you're going to see these same ones in lab. I guess there's a 3 on both sides of that. So these are 3 clastic sedimentary rocks. Which, by the way, what's the hint on the reference table for clastic rocks? Fragmental. So these 3 sedimentary rocks are made of fragments of other rocks. This one, I think, is the easiest one to see. What do you guys see in this rock? And I know it's not the best up there. What do those look like?
Yellow.
Do you see these like different pebbles? They almost look like fish tank gravel right there. And they're basically glued together. And if you could see up here, you can see that there's different colors of like glue that are holding them together. These are legit broken pieces of other rocks that get glued together. So are these. This one is sandstone. When you touch this one, it almost feels like sandpaper. Why would this feel like sandpaper? Because it's literally, sandstone is literally sand that gets glued together. So we talked about that on the other day. So these are clastic rocks. Now the first question was, how are they classified? And again, like we just went through, the only thing that makes these 5 rocks different from each other is going to be their grain size. So you always have to look at the size of the crystals on the inside, or not the crystals, the size of the broken pieces of rock to see which one is which. So they get classified by their grain size. How did we say the other day in our notes, how are clastic rocks formed? Yeah, so this is just, these I like to call clastic rocks, the classic sedimentary rocks. They just form when sediments and I do put glued. That's not how you spell glued, is it? Or is it? Yeah, it is. Get glued together. I'm having troubles with my writing. That says sediments get glued together. There are 5 examples on the reference table. I think you have room to write all 5. So there are conglomerate, I pronounce this breccia. I have heard it pronounced lots of different ways, including breccia. But I don't see breccia on there at all when I look at it. So I still am stuck with breccia. Sandstone, siltstone, and shale. Here's an example here of a crystalline rock. When we look at the reference table for crystalline, so there's technically 4 crystalline. We have rock salt, rock gypsum, dolostone, and limestone can be crystalline or bioclastic. Looking at this reference table, are these sorted by grain size like the last one? No, I see you guys shaking your head. They're not. If you notice, they all have a varying range of grain size. They can be fine to coarse. This one can be microscopic to very coarse. So in other words, the size of the crystals in a crystalline rock can be just about any size. So that's not what's determining if I handed you a pile of crystalline rocks. That's not what's determining if they're rock salt, rock gypsum, or dolostone. In this case, what is important to separate them? Yeah, what they're made out of. So if it's made out of halite, it's going to be rock salt. If it's made out of gypsum, it's going to be rock gypsum. If it's made out of dolomite, it's going to be dolostone. And if it's crystalline and made out of calcite, it'll be limestone. By the way, how the heck would you tell if something is made out of halite, gypsum, calcite, or dolomite? Which one? Yeah, the last page. So in the long run, you still will be able to tell which one's which based on the characteristics you already learned about minerals. So if I was to put acid on this and it bubbled, I would be able to tell it's calcite. If it easily was scratched by my fingernail, it'd be made out of gypsum. If it tasted salty, which is on here somewhere, it would be halite. So then if we knew it was halite, we'd know it was rock salt. So these are classified again by their composition. And how did they form? What did we say about these last week? Yeah, and if you didn't know, this does say here, right in the comment section. So they are crystals from chemical, precipitate, and evaporites. And I described precipitates and evaporites to you on Friday. It's a little bit extra of what you don't really need to know what a precipitate and evaporite is. Just know they are solids that form after a chemical reaction. Precipitates, they fall from the chemical reaction. So they've got a bunch of liquids and there's a chemical reaction and the solids will basically rain down to the bottom of the ocean or lake. An evaporite forms when water evaporates from like an ocean. Like if water from an ocean evaporates, the salt's left behind. That's actually how the salt mines formed. We got a bunch of salt mines around here out near Geneseo and Letchworth. We have a huge salt production mine, and that's because there used to be an ocean here, a salty ocean, and that water evaporated and left behind a pile of salt in Geneseo, of all places. So how do they form? Crystals from chemical precipitates and evaporites. There are 4 examples on the reference table. They are rock salt, gypsum, holostone, and limestone. All right, again, there are only 2 bioclastics. So limestone can either be crystalline or bioclastic. And then this bituminous, I think again is how you say it, coal. What are they classified? What's the important thing that if I handed you a pile of these rocks that you could put them in 2 different groups based on their. Yep, again, it's going to be composition. Again, they both have the same grain size. So grain size is not going to help us identify them, but what they're made out of will help us. So they are classified again by composition. Because there are 2 different ones, that's why I said formed from example, formed from example. Limestone, if you look at it, it is precipitates of biological origin or cemented shell fragments. And then bituminous coal is compacted plant remains. So we're going to put for composition, which one of those will be really the bioclastic part for limestone? The precipitates of biological origin or cemented shell fragments. Yeah, cemented shell fragments. That's going to be the bioclastic part. Why is that the bioclastic part? Yeah, so remember we've got bio, which means living. Plastic means fragments. So we want the fragments of living things. So that's where we've got shell fragments. So that one's going to be limestone. And the other one is compacted shell remains, or no, it's not, compacted plant remains. So technically, you didn't need to memorize any of that information because it was all straight from the reference table. But based on how well you guys are filling this out, I do think you need to make sure you understand how the reference tables work a little bit better. There is some stuff about sedimentary rocks that just isn't on the reference table, and that's the bottom half of here on page 25. So we're going to get these notes in, and then I'm going to give you like 25 minutes to work on your homework. So let's get started. I already have so many tabs open on my computer that I don't know where it is. All right, so the rest of sedimentary rocks. So sedimentary rocks are formed in horizontal layers. So one thing I want to make sure you understand is this means if I was to dig a hole, just like you guys do in Minecraft, or did in Minecraft. Okay, I know almost all of you have played Minecraft at least once in your life, some more than others, but hopefully you can go back to whatever the last time you played and channel that Minecraft person for a minute. What happens when you dig holes?
You go down.
You do go down. And what happens? What are you digging through? Layers. And those different layers, Minecraft's a little different, because once you get to, so first you dig through the grass, right? And there's dirt. Then what? Then there's some stone, and then there's solid, do you guys know what it's called at the bottom? Bedrock. That's legit how it works outside too. So if I dug a hole right here, right outside our window, I'm going to first dig through grass and then soil and dirt. Then I'm going to start to hit some more stones or clay or pebbles. It depends on exactly what's outside the window, like what was deposited there. But so first grass, dirt, then we start hitting sediments, and then you start hitting solid bedrock. And just like TJ said, those are in layers. Sedimentary rocks form in layers. Do not get that confused with they have layers, because if you notice on these sedimentary rocks, there are no layers in the individual rocks. So I know my daughters were taught, and I think I've seen a few of you guys do this too. They were taught hand motions to identify the rocks, and there was kind of like a little dance or song that went with it. Maybe you guys weren't. But one thing that they did for igneous, they would show that it was, you had to blow on it, it was hot. And then they did this for layers for sedimentary. Did you guys do this?
No.
Okay, I've seen a couple kids do it, so maybe they went to a different school. But sedimentary rocks, the rocks themselves don't have layers, but they are formed in very nice horizontal layers. So we could dig down through the dirt, through the sediment to the bedrock, and that bedrock would be in beautiful horizontal layers. So they're formed in layers on the Earth's surface. So these are not forming like intrusive igneous rocks. They are not inside the Earth. Sedimentary rocks form on the surface. Now keep in mind, guys, the surface does not necessarily mean the grass we're walking on. Even feet under the ground is still considered the surface of the Earth. Because keep in mind how big the Earth is. We'd have to dig down pretty far to be off the surface and deep inside the Earth. So sedimentary rocks, they form on the surface because we need that bedrock to get broken. Because we need sediments. We need living things to make those bioplastic ones. So they form on the surface because that's where all the weathering and erosion and biological activity take place. These are not like intrusive igneous rocks. These are more like extrusive, but again, they're forming here because that's where the broken pieces of rocks are found, are on the surface or up to 100 feet deep. Even 100 feet, I know that sounds like a big hole, is still the surface of the Earth. In case you're curious, the center of the Earth is approximately 6,300 kilometers below our feet. So even if we just dug a mile down, that's still way closer to the top of the Earth than the inside of the Earth. So the surface of the Earth is quite a ways down still. So because these rocks are formed on the surface, fossils are found exclusively in sedimentary rocks. So they can't be formed, or fossils can't be formed millions of miles or thousands of kilometers below the Earth's surface because there's nothing living there. The living things are living on the surface. So that's why sedimentary rocks are found on the surface. In addition to that, the formation of the other rock types would destroy them. For example, if a volcano is exploding on the Earth's surface, so where living things are, what would happen to that squirrel that was about to become a fossil if it was stuck in lava? It would definitely die, but it would burn up. So yes, we need things to die to make them a fossil, but we also need those bones and structures to survive the rock making process. And if something was stuck in lava, it's not going to, there's not going to be no bones left. They're going to be destroyed. So with igneous rocks, the fossil would melt right along with the rock. What would happen if a fossil, that squirrel, was then stuck in and was about to become a metamorphic rock? What would happen to the squirrel body if it was in a metamorphic rock? Would it make it through? How do we make metamorphic rocks? Heat and pressure. Do you think a squirrel body would, if they would break, they'd be too hot, they would get gooey? So again, metamorphic rocks, those fossils would be deformed and not useful for identifying them. So we will only ever find fossils in sedimentary rocks. So fossils in a rock are a dead giveaway that it's a sedimentary rock. And the last thing there, fossils will provide evidence of past environments. What I mean is, if you find a fish fossil in your backyard, what does that mean your backyard used to be? A pond or ocean or a lake. So if you find a fish fossil, they say that's a marine environment. What if you found a fossil of a tree? What used to be a forest? If you find a fossil of like a scorpion, what used to be that environment? Yeah, a desert. So a fossil will tell you what the environment used to be like for the environment you are finding that fossil in. All right, so that being said, it's time to practice the, get comfortable with the reference table. Can't do both those pages. That's a lot of homework. Let's start with, I think we'll do page 27 as homework. Page 27 has 26 questions on it. So it's a little more than I would give you just for a regular night homework. But because I'm giving you 10 minutes right now, I feel like 26 questions is not overloading you. Where will you find the name of two bioclastic rocks? Yeah, in your reference table. This is all straight from the reference table. Bioclastic, limestone, and bituminous coal. So there you go. You only have 25 questions to do for homework. Page 27.